In this video, we're looking at the problems on page 12 of the chapter 2, section 2 slides. So in each of these, we're supposed to determine if the matrix is in row reduced form, and if it isn't, then we have to say what's wrong. So first we've got A here, where we've got 1, 0, 0, 0, 1, 0, 0, 0, 1, and 0, 0, 3 for our solutions, and this is in row reduced form. In B, here we've got 1, 0, 0, 4, 0, 1, 0, 3, 0, 0, 0, 0. This is also in row reduced form. Too many R's there. And let's just remember what the rules are for row reduced form. We should have each row consisting entirely of zeros needs to be below all the others. So this last row is the only one that is all zeros, and it's below all of the others. The first non-zero entry in each non-zero row is a 1. In any two successive non-zero rows, the leading one in the lower row lies to the right of the leading one in the upper row. And if a column in the coefficient matrix contains a leading one, then the other entries in that column are zeros. So, with that information, we can say for sure that C is also in row reduced form. All of those rules are followed. The one place where we have a non-zero entry in the coefficient matrix is that 2 in the first row, but there is no leading one below that. In D we have two problems. The first is that there's a leading one in the second row with nothing above it. So what we should do here is switch the first and second rows. And also, we have a 2 above the leading one in the third row. So we should subtract 2 row 3 from row 1 to get rid of that 2. In E, so I'll just say this is not row reduced form. In E, this isn't row reduced form either, and it's that same second problem we had. We've got a 2 in the third column, but we also have a leading 1 in the third column. So we want to get rid of that 2 when we have a chance. It's also notable that this would come up with some inconsistencies because we would wind up with 0 equals negative 0z equals -5, and that just doesn't work. In F, this is also not in row reduced form because we've got in the second row 3y equals 0, and that's fine. There's nothing that says that can't be true, but it is important to note that if we have 3y equals 0, we can rewrite that as just y equals 0. So this should be a 1, 0 when we divide the row by 3. Finally, in G, the only problem is that that row of all zeros should be at the bottom. So this is also not in row reduced form. If there are any questions, let me know.